I don't know why. I guess we can thank ForeFlight for that. Paper charts have value. They don't take batteries. They don't break. Right? It's easy to put them on the wall and show a couple key points. I agree, and I like the digital platform. If your operations are approved for the EFB, for an electronic flight bag, then you can fly the airplanes in accordance with those operations. And those operations that require op specs, Part 135, 121, whatever. The 135 carrier that I work for, we just went through the EFB process. So we can use electronic flight bags, and we don't have paper charts anymore. It's really nice. It's very good. But the key components and the key elements still exist. So going through section C, the very first thing that we have to look at is latitude and longitude. As aviators, we should know how to find a point using latitude and longitude. It's not uncommon for me to find that pilots don't know how to do it. Now, you'll do it on the written exam because there are some questions on the written exam. You see here on the lower right-hand corner, and I'll just use my laser pointer, I've got 100 degrees and 44 degrees, correct? So these are your latitude and longitudes. The way I always remember latitude and longitude is latitude is a lot like a ladder. You guys are familiar with a ladder, right? You climb a ladder to go on top of the roof. It's got rungs and you climb up the ladder. Okay, so the exact same thing. I'm climbing up the ladder as I go up the latitudes. Okay, they're also parallel. All of the latitudes are parallel. The longitudinal lines, the lines that go long ways up and down like this, these lines all converge on that true North Pole and the true South Pole. So we get true North and magnetic North from the two. These two are not the exact same. So that line right there, that line next to the 100, this goes all the way to the North Pole, and it does converge. So this line and this line, although they look like they're parallel, they are not exactly parallel. So I can't call that a rectangle. What they call it instead, they call it a quadrangle. Okay. For instance, a quadrangle, each quadrangle has a maximum elevation figure. And that tells me that there's somewhere within this quadrangle there is an obstruction, whether it's terrain, whatever this is, a transmission line or whatever that is, I don't know. It could be a TV antenna. It could be a light pole, who knows. But it's an obstruction of sorts. It could be terrain. It could be whatever. There is something that could cause a hazard at 3,300 feet. That's your maximum elevation figure. Okay? So this quadrangle is defined by, again, your latitude and longitude lines. Look at the latitude first. Latitude says 44 degrees. 44 degrees implies, although it's not listed, it's not depicted on here, but 44 degrees implies that I am 44 degrees north of the equator. It seems really, really super simple. The north part is usually pretty simple. As I move upwards, that number will increase because this is a north unit. That's 44 degrees north of the equator, and the equator is way down here. Each one of these lines, these small lines, are what they'll call tick marks. The T-I-C-K, tick marks. Each one of these small tick marks are 1 degree. So 1 degree of latitude as I go up. Then I have this tick mark, which is a little hard to see because there's an obstruction there, but I can see it here. See how it's just a little bit higher than the smaller ones? So each one of these intermediate tick marks is 5. So I can count 5, 10, 15, same thing. 5, 10, 15. At a glance, I know pretty close to where we are. Each one of the long tick marks like this, that go straight across the inside and the entire side, that's 10 degrees. Okay? So 10 degrees. Each one of these is also equivalent to, very close to 1 nautical mile. Because that's how a nautical mile is defined. A nautical mile is defined as 1 degree of, or excuse me, not 1 degree, but 1 minute of change, of longitude change at the equator. Okay, so just 1 minute worth of change. So here I got 44 degrees and 5 minutes. 44 degrees and 10 minutes. 44 degrees and 20 minutes going up the scale. Below here, each minute, of course, has 60 seconds. So below this 44 degrees, I have 43 and 55 minutes. 43, 55, I got 56, 57, 58, 59, and 44 degrees. So that's your lines of latitude. The line of longitude is a little more counterintuitive. It doesn't make sense for us. Here, if I want to read this book or this syllabus or any book or anything that I have over here, I'm going to read it from left to right. I'm going to start over here, and then as I go this way, I kind of expect things to increase as I go that way. The same thing with all of our charts. All the charts and the drag, total drag, speed, and everything else, it's always increased to the right. It doesn't do that with your line of longitude because it's the prime meridian and we're in the western hemisphere. So now I have 100 degrees, but as I move to the left, the number increases. So this is 100 degrees and 1 minute. 100 degrees and 5 minutes. 100 degrees and 10, 20, 30 minutes. That's why this one's not labeled, because it's 100 degrees, 30 minutes. Now the next one that would be on the other side over there, that one is 101. Okay? 100 degrees west. 100 degrees and 30 minutes. So again, this whole area, if I want to approximate distance, I can approximate distance on a VFR chart in a couple of different ways. One way is for me to just take my fingers and put it across these two lines. That's 30 nautical miles on a sectional chart. So if I need to do a diversion, and I'm not approved for electronic flight bag, so I have paper charts. If I need to do a diversion, I'm flying my airplane, I'm not going to get out a flight computer and a plotter and a pencil. I'm going to crash the airplane trying to do all that crap. Just take your fingers. I know, well, that's 30 miles. I got 30, 60, 90, 120 miles to where I'm going. That's a good estimation. You'll be very, very close. What I call a swag, or a sophisticated wild ass guess. That's all you're doing. You're making a pretty close guess. Okay? Another thing that I can do with these lines is maybe I'm flying my airplane and during that diversion I want to get a pretty close estimation for the direction I need to fly. Okay. Maybe I'm here and I want to fly over in that direction. So I take my pencil and I put it here. And now I can see this is about a 315. Just using that pencil and these lines, I could rapidly identify approximated headings at a glance. Maybe I'm over here and I want to go to that airport. restricted airport, okay, that's fine. Maybe I'm allowed to go there, or I have an emergency. I'm going to go there whether they like me or not. Just go like that. What's my approximated heading to go over there? Well, that's 180. This looks like maybe a 210, 215. That's an approximation, which is exactly what you want to do in a diversion. And then how far away is it? Well, this is 30 nautical miles. It looks like about 30 nautical miles. If I'm flying at 120 knots, that's 15 minutes because I'm doing 2 nautical miles per minute. Easy. Rapid estimation and rapid situational awareness to a changed plan. Very important things that as aviators we should be able to do. If it takes me more than a minute and a half to figure out basic distance, time, fuel to a diversion, it's taken me way too long. Okay, remember it's not supposed to be a science project, it's just a quick, how much fuel is this going to take for me to get to the new place? All right, a couple of other things. Let's see, I got to go over latitude and longitude, projections. And so if we're putting the Earth's surface on a flat piece of paper, you know that as a projection is going to cause those areas near the poles to spread out. It'll look much larger, much wider than it actually is. One of the things that we need to cover. All right, sectional charts. In sectional charts, we'll have legends, something that I don't get in my foreflight unless I specifically choose to show the legends, and you can do that. Now you'll have all of your legends for that chart. But I have my legends such as this legend here, and I'll also have a published date. Now the sectional charts are published, if I'm not mistaken, I'm pretty sure I'm right on this, sectional charts are published every 6 months. So every 6 months I need to get a new sectional chart. The IFR publications are published every 56 days. So when I'm doing IFRs, every 56 days I'm buying new charts. These things, if you get one, what you have is probably good for 6 months. If there's one at the school that's still good, use that one. Probably has some pencil marks in it. Hopefully not pen, whatever. But you erase those pencil marks and you use it good as new. All right? But some of these, like for instance, I may have radio aids to navigation. Look at this one. This is a VHF Omni range, or a VOR. Something I can use where they're still being maintained, and there's some that are still being maintained. Some that will be maintained always. But something that I could use to help me navigate from one point to another. A VOR-TAC, which is a VOR with a TACAN receiver, or a TACAN transmitter. And TACAN transmitter is tactical navigation used by government aircraft. That's fine. It also provides the exact same information for civil aircraft as a VOR DME. So VOR with distance measuring equipment, that's very valuable. Say I have a VOR receiver here, or VOR transmitter here. Well, I got another one over here. How many of these VOR transmitters do I need to determine my position? It depends. It depends on what kind of equipment I have in my airplane. Now we're going to go on these flights in a Cessna 172 slant, some sort of slant code. I either have that, or I have that, or I have that. So slant uniform, slant alpha, or slant golf. Either I have a VOR, just a VOR, or a VOR and DME, distance measuring equipment, or I have some sort of RNAV, GPS. If I'm in this airplane, which is also called slant useless, I have to have 2 VORs to determine the position, right? Because if I'm here, I need to know what direction I am from that one and what direction I am from this one. But what if I don't have this at all? What if I don't have that other VOR? Is there a way for me to determine how far away or where I am exactly from that VOR? I can.
Yep.
but I have to use this. I have to use a direction and a distance. That gives me an exact location. Because if I have this airplane, I might know what direction I am from that VOR, but I don't know where on that line I am unless I have another one to show me, yes, I'm also over here, and intersecting lines, right? Mm-hmm. Now, GPS certainly makes it a little bit easier. We can determine where we are kind of at a glance or whatever, but I encourage pilots to use their backup systems as much as possible, to think about how could I operate degraded? How could I operate if I did not have this GPS for whatever reason or whatever? Okay, so those are some radio aids to navigation. You also have non-directional beacons, a couple other communication boxes. That's fine, just a sample legend there. Obstructions. This does not say antenna. That's just maybe a quirky thing about me. It doesn't mean it's an antenna, it's an obstruction. It could be anything in the world. If they're 1,000 feet and higher, they have kind of a little stick on top of it. Okay? If it's below 1,000 feet, you just have the triangle. If it's a group obstruction, well then you just have two of them together at once. That tells you there's more than one. Go over there to Palm Beach, they got group obstructions. Go over there to North Perry, you got group obstructions over there. Those say next to it that they are TV antennas. Well, that's fine, that's what those are. Obstruction with high intensity lights, you got the lightning bolts kind of all around it, and that's fine. And then you have these things. The bold italicized numbers and the numbers in parentheses. And then sometimes you'll have a UC. Now, I got this slide on here because of some of the questions that one of our popular examiners will ask. You guys may remember from yesterday, I'm really not a teach to the examiner type of instructor. I want you to be safe in all environments. I think if I help you understand, apply, and correlate the information pertinent to your certificate. So I help you all the way through private pilot. I make you the top-notch private pilot. You should be able to go to any examiner out here and pass the check ride, right? You should, okay. But some examiners have interesting little things about them. And one of the things that Nielsen will do commonly is he'll find something on the sectional chart that you don't know. It's okay. You won't know all of them. But he found this, and I decided to put it in the slides so you guys wouldn't get caught off guard by it. So just real quick, going back to one of these, take a look. This has an obstruction. I know it's over 1,000 feet AGL at a glance because it has the little stick on top. And this is the altitude above mean sea level. So in other words, this really is my true altitude at standard conditions that I would find the top of this obstruction. This is the value in AGL, or the absolute altitude. A pilot once, a flight instructor once told me something that I didn't forget, and that is, if I hit this obstacle, that's what my altimeter would say, and that's how far I fall. Right? Kind of helps me remember that stuff. Now, what in the world is UC? Well, there it is right there. We just saw what it means on the other side. Under construction or reported position and elevation unverified. So this is under construction. I'm not sure, it may be higher or lower than that. Okay. All right. Airport has service. These are tick marks. The word service was recently changed to also specifically imply fuel. So if I don't see tick marks, you guys see this tick mark thing, right? They use the word tick a lot. These are tick marks. Those are tick marks. If I don't see any tick marks here, I know that that airport does not have fuel.
No fuel. Has no fuel.
Does not have fuel. I didn't know if you said nav fuel. It does not have fuel. So let's say I'm making a diversion, right? There's a bunch of different reasons why you would have a diversion. I have weather that's causing me to divert. I have a precautionary situation, some sort of abnormal situation. The airport that I wanted to go to is closed. I don't know why. There could be all sorts of different reasons. Maybe I have a sick passenger. Maybe I have to go to the bathroom really, really bad. Right? There's a lot of reasons that exist that I might want to divert. Okay. If one of the reasons why I want to divert include me needing fuel, well, I want to make sure that I see these on the airport that I'm going to, right? So check to see that the airport has fuel that you're going to, or services if you need that. This is the airport data block. That's the name of the airport. This is the identifier or 3-letter code, 77 Golf. 895 is the airport elevation. I have a star. That star will indicate part-time. That star or asterisk indicates part-time. Part-time lighting for us. There you go. Does not imply pilot-controlled lighting, but I would normally assume that this means pilot-controlled lighting, especially in 2020. That normally means that I should have pilot-controlled lighting. Either way, it's part-time. So it might not be available to me if I show up off hours. The 38 tells me that the longest runway there is 3,800 feet. And 122.8 is the Common Traffic Advisory Frequency, the CTAF. That means Common Traffic Advisory Frequency. That's the frequency I'll use to broadcast my intentions and to monitor for other airplanes or aircraft. Same thing with Sandusky, very similar in nature. There's my CTAF. Okay. Either one of these airports have a control tower?
No.
How do I know that?
Magenta.
They're both magenta and not blue. If they were blue, they would have a control tower. This star at the top of the airport depiction means that it has a beacon, a rotating beacon. So the white and green lights that I need while I'm trying to find this thing at nighttime, it has it. Okay. There's another airport of sorts. I'm not sure. This is probably private, but doesn't have any information about runways at all. Okay. So a couple of things there for the sectional chart. Now, aeronautical charts and chart symbology, you could spend the rest of today and probably all of next week learning every single one of the depictions that are on here. Every single one of these little lines and figures, these all mean something. The best way of accomplishing this is to compare your chart to the legend and read the legend. Go through that chart on a daily basis and read the legend. What does this little yellow spot mean? Well, read the legend. This is a populated area or a congested area, right? Why in the world do I have a 0 here with an arrow like that? Well, this is a vortex, And this is the magnetic direction of that vortex when it was last surveyed or when it was installed. Doesn't mean that that's magnetic north. It was magnetic north when that facility was installed. I have a data block here for that facility. That's PEC VOR. It has HIWAS available. There's the VOR Morse code for ECK. Channel 87 for anybody that's using this for a TACAN channel because it is a VORTAC. 114.0 megahertz for me using my FM radio to navigate using it. They have a remote communications outlet here for Lansing radio that I could use and contact on 122.1 and then monitor their transmissions over 114.0. During their transmissions, it will interrupt the HIWAS. So a lot of information that I have that's available here. Continuously reference your chart legends. Okay, a couple other things. VFR waypoints. A couple of ways to do this, or VFR checkpoints rather. It could be pictorial, so they show an actual picture of an arena or a government building. The arrow will indicate that that's a VFR checkpoint. If you have an arrow, this tells me that ATC will commonly use that VFR checkpoint while making reference to your flight path. We have some of these in the area here. We have the bend in the Sawgrass. You have the West Dixie Bend. You have the landfill near Pompano. There are several VFR checkpoints, and you want to become familiar with those as you go into an unknown area. Otherwise, the ATC is likely to tell you to report the bend in the Sawgrass, and you've never seen that place before in your life. Never even seen it on a chart. You don't know where that is, right? It could be a VOR facility. I could find that. I could look for it, but I also tune in and identify with a radio. It could be an airport, right? And none of these are shown on the World Aeronautical chart. So that big world chart, there's one of these that show the entire United States on one page. You're not going to see your VFR checkpoints on those. Terrain features. Here I have sea level, below sea level for New Orleans and places like that. And then going all the way up to whatever elevation I may have. Okay. And different shades for the corresponding elevations. Florida, for the most part, is all right in here. This is it. Yeah, I don't even know that we have any of this. Very, very flat land. Warnings and caution notes used when specific area is not demarcated. So, there's not an outline, it's not depicted on the chart, but I have warnings and notes. Extensive fleet and air operations being conducted in offshore areas to approximately 100 miles seaward. Maybe I have that near a naval air station. All right? It's just a warning. Doesn't mean I can't fly there, but kind of precautionary. Caution, be prepared for loss of horizontal reference at low altitude over lake during hazy conditions and at night. Well, it sounds like they got a lot of steam fog there. Or maybe some radiation fog at nighttime. We have some of this. In South Florida, we have a lot of this. Flights over charted U.S. wildlife refuges, parks, and Forest Service areas. Landing of aircraft is prohibited on lands or waters administered by the National Park Service. All right. Emergency, all the prohibitions go out the window. I'm pilot in command. I have the final authority to operation of that airplane. I can deviate from any rule. So we have emergency, we're landing there. Okay, I got that. But barring an emergency, we're not going there. U.S. Fish and Wildlife Service or U.S. Forest Service without authorization from the respective agencies. We have some exceptions. When forced to land due to an emergency. Okay, great. An officially designated landing sites or an approved official business of the federal government. All right. If I'm not any of those, then I must adhere to this. Pilots are, it says, requested to maintain a minimum altitude of 2,000 feet above the surface of the following: national parks, monuments, seashores, lake shores, recreational areas, scenic riverways administered by the National Park Service, wildlife refuges, big game refuges, ranges and wildlife ranges administered by the U.S. Fish and Wildlife Service, and wilderness primitive areas administered by the U.S. Forest Service. All of those areas are marked off by this demarcation. Almost all of South Florida is marked off with this. All the Everglades and all, that's all protected. Those are all wetlands. Why do you think it's still there? Have you seen Miami or Broward County? We don't have a lot of room left, and people are just building on top of buildings on top of buildings. If this stuff wasn't protected, we would have already had a city from here to Fort Myers, okay? This whole thing would be city, but we can't, and it's all protected. What does that mean? We're not supposed to fly below 2,000 feet out there. All right, keep that in mind. Okay, airspace. Let's jump into it.